talk of tonight is AI didn't break testing. It just made bad decisions faster. This is maybe something you will have seen or heard, and excuse me if I do funky things with my glasses. I'm at that very awkward stage in life where I can't see far or close very well. So, you know, I have to choose my poison here. So maybe you have seen something like this, you know, any vendor, and I see plenty of them. They solve whatever problem you want to throw at them. There is an AI thing now that can solve your problem. I have a background in software quality engineering, so that is what I see most and what I know most about. Maybe you have heard it, you know, one of your managers saying, use this tool, be twice as productive, everything is going to be fine. Then we can fire all these people over there, you know. Or maybe you are on LinkedIn someday and you scroll through your feed, right, and you see posts like this. It's like, God, he's dead. Nobody cares anymore. They just all push slop out and out and out and out. And, you know, what do I do now? So I think these are two sides of the same coin, really. So I'm going to talk a little bit about why I think that is. However, what these two things have in common, in my opinion, is that they treat AI as the actor. But AI is not the actor, we are the actors. AI is just a tool. So AI didn't break testing, but it made bad decisions faster. And if we want to understand why that is, I think we need to look back a little bit and look at the things that were already broken before AI came along and made it easier for us to, you know, break things faster. And as I said, there are two voices now, briefly. So I think a lot of people who talk about AI broadly into two camps. There are the enthusiasts, AI is going to solve everything. Yes, miracles, right? And then there is the other side that go like, no, AI is destroying everything. The naysayers. And neither of these is new. I see that a few of you, like me, have been around for a day or two in this you know, industry. So we have been before. And I just put a few examples on the screen off the top of my head, right? Configuration management, infrastructure as code, virtualization, containers, CI/CD, now AI code and test generation, right? And all of these always had camps attached to them that said, yes, this is finally going to solve all our problems in software engineering. And other people say, no, this breaks software engineering. This is horrible. We cannot work like this. So, you know, same script, different costume. But a few things haven't changed. And I think it serves us well to look at those. And for me, again, I have a quality background, so that's kind of the slant of this talk, obviously. There are two questions that I keep returning to. And that is really, what does good enough mean for what we're building? And how do we verify that we have actually built that in an efficient manner? So that is, for me, at the heart of all of this, right? Tools can make this easier or not, but that is really every tool, every wave of tools that I have seen kind of promises that these questions will go away, and none of the tools I have seen actually makes them go away. We still have to make those decisions. So AI didn't break testing. It did make bad decisions faster. And that, there are many reasons for that, but I'm going to talk about three. And first of all, AI is an amplifier, right? So if you already have good engineering discipline in place, it will amplify that. If you don't, well, it will amplify that as well. So anybody here spent more time fixing than prompting last week? Yeah? Because I had a day like that, definitely, right? I definitely had a day where I was like, no, that is not what I meant. What? No. So yeah, so it still happens, right? And that is a pattern I see in the workshops I give quite often. And it boils down to really teams with good engineering discipline. They see a lot of gains through using AI-enabled tooling. Teams who don't have that same, they lose a lot of the kind of so you can speed up certain parts of the process. But if your entire setup, if your entire engineering discipline, if your SDLC is not set up for that, then you will lose that speed at a different point, because then you need to go back, verify, and fix. So that is kind of the vicious cycle. Luckily, however, you don't have to take my word for it. AI does not automatically improve software delivery performance. It acts as a multiplier of existing engineering conditions, strengthening high-performing teams while exposing weaknesses in organizations with fragmented processes and poorly structured development systems. This is from the DORA report from last year, the state of AI-assisted software development. So we can assume that they know what they're talking about, right? Stack Overflow did a survey. They asked, I don't know how many, and the outcome of that was that 45% of developers say that debugging the AI-generated code takes longer than just writing the code. I was just chatting to one of you here in the room who told me when they took away the AI assistant coding, people didn't remember how to code. Right? So that is not a great reflection on the state of things. I think it works quite well. So I do write code. I've never been very good at it, so I do probably what many would call vibe coding these days. If I need a quick tool for something, right? That Claude helped me with that. And I find it works really well for narrowly, clearly defined tasks, but anything that gets a little bit more complex goes wrong quickly. So, there is a little bit of discipline to be had there as well. So AI didn't break testing. It didn't make bad decisions faster. And that includes the decision how we use it. So I think, and this is the second point, that we often use AI for the wrong work, or the wrong kind of work. I think we have a tendency to not let AI do the easy things and throw it at the harder things. And I think that is, excuse my French, ass backwards. So there are other studies here. This is from a study Microsoft and Carnegie Mellon did that has been peer-reviewed. It was only 319 people, but you can see what it says here, that 70% of them reported less cognitive effort on an analysis task. The next bit is my personal pet peeve. 58% agreed that AI did most of the thinking. No pet, AI does not think. Doesn't happen, right?
Yeah.
40% of the tasks, they just didn't use any critical thinking at all. They just accepted what AI produced for them and went on. And that, of course, is tricky. Oh, come on. There we go. So AI is really good at what I'm calling the grunt work here. Right? So that is the easy stuff, like boilerplate code, data setup, obvious assertions. All of that is really great. Shifting through large amounts of data. AI, great. But judgment calls, things like a test strategy, like, deciding what you want to test, deciding how much risk is attached to the different system parts of your system, to the changes you're making. AI is really bad at that. You don't want your AI tools to do that. You can use them to provide you with information to make that decision more easily, maybe make better decisions. But you want to make sure that you do the judgment call. Right? AI really not good at that. Because, as we have seen in the numbers from the knowledge workers, basically what AI does is it can make the reasoning step disappear if we let it do the judgment, right? We just get a bunch of facts thrown at us and a conclusion, and then, okay, all of these facts sound great. Yeah, the conclusion sounds okay to me, but we have not actually had time to reason, to do the reasoning ourselves. Now, in my role, I would argue that both as software developers, but again, software quality testing, right? Reasoning is the whole point of why we're doing what we're doing. The mechanical execution of creating code is not the interesting part. The reasoning about it is the interesting part, it's the hard part, it's the part that is human and that we should continue to do. And then there is a thing that is called the jagged frontier. And the jagged frontier is basically the separation of tasks where an AI tool is really helpful and where an AI tool is not helpful. And you cannot easily, so it is not a straight line. You cannot say there is a task that's on this side and there's a task on this side. You can also often not decide what side a task falls on. Some two tasks may look very similar, but one is a task that will benefit from AI tooling, another will not. And that is where we do a lot of misallocation. So as I said before, grunt work is often inside this frontier, right? So you can pass that to AI, that's fine. However, judgment almost always falls out of it. There may be some like lower judgment functions where AI can sift through a data set and make pre-judgment calls. Say, okay, you need to look at these things and these things here don't mean anything to us. That's fine. That is not really what I mean by judgment call. But deciding on whether any of these things, for example, is something a real risk to my project. Do I need to write more testing here? All of these code decisions really fall outside of it, on the other side. And that is where using AI will probably hurt your product rather than helping it. So, and these things are basically, again, two sides of the same coin, right? The amplifier is on the outcome side of the things, where the misallocation is on the core side of things. The team's discipline is a variable in both of these. So that's kind of what glues this together. So if you remember one thing, really make it the jagged frontier. The delineation between good tasks for AI involvement and not is not as clear as you may think. So AI didn't break testing. It did make bad decisions faster, including the decision we make before we start prompting. As I said before, parts of our job have not changed. It is still defining good enough and verify it efficiently. That is a big part of what we do. What changed, however, is when that has to happen. These changes, and I mean, I have been around in this industry for about 20 years, right? So I have seen shifts from, I started working in a company that prided itself in being agile at the time, and I think they probably were. I worked in many other companies, all of which kind of considered themselves agile, minus one. I worked for one company where I proudly, during my interview, told them, I know everything about agile, and they were like, yeah, we don't do agile. I don't think we ever will do agile. A year later, of course, they brought in consultancy, blah, blah, blah. Anyways, so previously, a lot of this kind of verification quality stuff was during the writing and the reviewing of the code. And I think all of that needs to be, and we know this, right? We know that we want to move all of this to the left and to the right and to everywhere. But AI makes this even more urgent. So any company that is still thinking they can actually verify all of the AI-generated output at the end of the output is going to struggle. The people doing that are going to struggle. So really, what we want to do is create, so there are many points where we can do that. Again, I will talk about 3 examples where I think this is going to be a quite easy concept. There are certain artifacts that we all know how to create and that I think are going to be really helpful in that. The easiest one of this is a style guide. The next one is a list of the patterns that we are not going to use. So, you know, basically, if you want, it's your style guide and your anti-style guide, right, rules. And then I find it incredibly helpful if we can provide an example of this is what good looks like here, right? So You have the kind of slightly more theoretical style guides and then a concrete example. This is something that you can give a new starter in your team. And I have worked in companies where this exactly happened and where I find this incredibly helpful, right? So your AI tooling probably needs this as well. And it is really important to remember that none of your AI tools will be in your retrospective. So they can't absorb your organizational knowledge like people do. All of this needs to be codified somewhere where it's accessible to your AI tooling, right? It can't be in the heads of people anymore. And that's what I mean when I say it made standards visible. It made them visible, urgent, and I think impossible to skip. Because if you skip codifying those standards in a way, again, that is accessible to your AI tooling, then you will find out in 6 months. And not in a nice way. So AI didn't break testing. Why then do we see this conversation that keep going everywhere? It's like it did. And again, if you scroll 5 minutes through your LinkedIn feed, you will probably see that. You will probably see a bunch of companies who have laid off a whole lot of people. Quite often they start with the QA people. Sometimes it will be junior engineers. It will be, all sorts. Technical writers, I think, are really on the verge right now. So anyways. And I think there are arguments to be made, or there are arguments that I see people make, and this is probably the argument that I have the most sympathy for when people talk about why AI is horrible. And I kind of call it the purity position. And it is, and none of this is wrong, the slop is real. We have all seen it. And those people just say no, refuse to use that. Don't do it, right? We need to defend our craft. Now, again, what do you say to that? Because they are not wrong. There is a lot of slop out there. And again, I spend probably too much time on LinkedIn where it is extremely visible. I spend time with clients in code bases where it's also sometimes extremely visible, right? So you have all sorts of examples for that. And there is something underneath that, I think, which is a little bit more emotional. Because if you have spent 5, 10, 20, 30 years honing your craft, and then this tool comes along and kind of regurgitates something that is nowhere near as good as what you think you could produce or should produce, right? I would call that grief. Right? And I get that. But I don't think that it is a legitimate strategy. I think it is a losing strategy, unfortunately. And I say that because once something has become cheap enough to allow mass production of goods that people want, the conversation moves on. People no longer talk about the quality of the craft. Now we're talking about how can we make this available to as many people as possible? How can we profit from this as much as possible? We may not like that. I don't particularly like it necessarily. But if history has taught us one thing, then it is we're not going to win this. We have been here before, right? So the Industrial Revolution happened, not in our lifetime, of course, right? But that was the first mass conversation that was a very similar point. We have craftsmen who produce handmade quality items, and then we have mass-produced items. Craftsmen didn't win this. Some of them still exist, right? I cannot afford a pair of handmade shoes. I would love to, but I can afford shoes, right? So choose your poison, I guess. This throws us back to the question of what does good enough mean? Where do we draw the line now? Because good enough, if you apply this to code, It is no longer the carefully handcrafted, beautiful, I turn your 20-line function into a one-liner. Much as we all love that. Does it run in production? Can it get to production quickly? Is it safe to run in production? Great. I don't care what it looks like. You kind of have these two positions now. That is unfortunately where we are. And yeah. The other point that you will see a bit or a lot is that AI introduced new problems. We suddenly verify problems that we haven't seen before. We have hallucinated APIs maybe, or maybe the whole non-determinism is a big problem for specifically automated testing. Volumes of code that and again, this is another thing that we come back to time and again. Often people's knee-jerk reaction is, well, humans have to review all of the code that is AI generated. That, again, is not a winning strategy because you cannot physically do that. People cannot review that amount of code. You can, or you create a bottleneck that doesn't make it worthwhile you are using AI in the first place. Again, pick your poison, I guess, right? However, I would also say that the artifacts of the problem are new. The problems themselves are not new. We have dealt with a lot of these problems in software engineering for a long time. We need to verify our API calls anyways. We are not always in control of the other end of the API, so we have methods for that. Right? That happens. Non-determinism is not a entirely new problem. Right? There are methods for that. The sheer volume of code is maybe a new problem. So we need to talk about how we can scale reviews in a way that works and that matters, and not just do the knee-jerk, somebody has to review everything. Well, and training data contamination and drift, again, none of these are really new problems. Data contamination is not a new problem. We have seen this before. We have methods to deal with that. So I think a lot of people get a little bit overexcited when we talk about AI and forget a little bit about the lessons that we have already learned in software engineering and how we solve problems, how we think about problem solving, and how we apply those things. So I've talked a little bit about the traps I see. I want to talk a little bit about what you can do practically. Again, all of these are suggestions. All of this is very context dependent. Your organization may be very different from your organization, right? I mean, security needs, for example, are different, customer needs are different, and so on and so forth. So don't think I'm trying to tell you what to do here. I just want to walk through a few examples of what I think can work and what I have worked with my client on. So the first thing to remember is you own the pipeline, right? So think about where in your pipeline AI should actually sit. And there's probably not just one specific spot, so it should not just be in the code generation, right? There are other places where we can go. So again, you don't want to do the strategy bit, or you want to have AI do the strategy and then humans execute the boilerplate tests, right? That is crazy talk. Don't do that. AI-generated tests can be good, but only if you have very clear rules and guidelines in place. If you have guardrails in place for those tests. Standards cannot live in people's heads. I talked about that. They need to be codified in a way that AI can actually access them. And then, well, I mean, flaky test suites are hardly a new problem, right? We probably all have dealt with one or two in our time. So you want to look at that. And I'm going to talk about a little bit more in detail. So basically what I'm going to say is these 4 moves will get you to a better place. Start using AI for the grunt work rather than the strategy work. Gate the output, encode your standards, and close the flaky loop. And again, I have some suggestions on what you can do and what you maybe don't want to do. So the grunt work, right, we talked about test data and fixtures, fine, boilerplate, scaffolding, all fine. There are some obvious assertions that AI can do just fine. What I really like is or having AI analyze a stack trace for me and write a test for exactly what it finds. That is great. The decision I want to make then is, however, do I want to keep this test? Is this a test that should now live permanently in my test suite, or is this something that I just use as an analytical tool to learn something? So that is something. Again, what we want to decide ourselves is what is worth testing. I know, so when I was a QA engineer, the expected answer was, well, everything? No, not everything. Really be a little bit selective. Assess your risk. We want to make release calls, and by we want to make release calls, I don't mean a cap that, signs off on that, but we want to know what gates we have in our pipeline that determine whether something is going to be released or not. Again, the shape of our test suite, definitely something I want humans involved with. And sometimes I also want a human to look at failures and decide on whether is this a real failure or not. But again, this is not a new problem. In one of my jobs, I remember that company was extremely fond of screenshot comparison tests. And one poor soul came into work every morning and spent the first 2 hours of their day looking at screenshots, trying to decide on whether there was actually something wrong with the UI, or whether there were just 3 pixels over here that didn't render quite correctly. That was not a great job. We don't want to do that, right? So kind of. Again, I think we want to map AI to our pipeline stages. And there may be different tools, but there are definitely different setups for the tools at the different stages, right? So again, pre-commit boilerplate test is great. Coverage diffs is a great use for an AI tool, for example. They can do this very quickly. They can give me a report, and then I can have a look at the report and decide if I want to do something with that or not. Right? So, and again, do this at all of the stages. So I don't have to read to you what's on the slide, right? But do this left, center, right, in the whole. Again, I talked about this. AI doesn't absorb institutional knowledge. It cannot do that. And probably, who knows? I like to think it can't, so I would argue we should probably make that intentionally available. So make your standards machine readable, right? Again, a rules file, a pattern we don't use list, a golden test that you would merge. So again, this is just for the testing bit. That is really good. You probably, it is more and more, and I was again talking to somebody earlier, this talk is about 6 weeks old and things move very quickly, as you have maybe noticed in the AI world. So at this point, we are probably a lot people I talk to coming to the conclusion that actually we want a real code scaffolding around that, and we're moving away from AI reading its own tool, right? We're going backwards a little bit. So I would keep that in mind. However you do it, you want to make sure that you can control these kind of moving parts. And your standards, kind of talking ahead of my slide here, standards as a code, not as a wiki page somewhere. Right. And then, and this is maybe the most important bit, AI is going to produce stuff faster than you can review. There is no way around that. So we need to think about what we can do about that. Again, there are ways in where we can use AI safely to review code output. I think what I didn't put on the slide here is, if you have an Gen AI model review your code output, try to use a different model than the model that wrote your code, because those things unfortunately have what's called a familiar I think, familiar bias, right? So they judge code that is written by this same model more positively. So kind of, you want to play that off again, a little bit against another. I think AI tools are really good at a first pass review. They can spot a lot of things. But again, they need to be fine-tuned to where do I need a human, when I need to escalate this to a human, to somebody who actually knows more of the context. Right? I saw one, it's an older, I think it was Smart Bear study they did in, honestly, I think it was 2010 maybe. And they did a study about people who reviewed code and basically measured how much code somebody can realistically review well. And it's an hour. After an hour, concentration goes like that. And people continue reviewing, but they don't really spot things. Another outcome of that study was that I have had many conversations with people who think code reviews are great for spotting bugs. Actually, no, they're not. They're really not. They're great for knowledge sharing. They're great for kind of, getting people to work in the same way and understand and share context and all of that, but they're actually not very good at preventing bugs. Which is funny because a lot of people still think that is the case. It's never have been and never will be, I think. So my favorite tool for that is some mutation chain testing. That is a fairly quick and easy way to figure out which of your tests actually do work and which of your tests just look great. Because that is another thing that AI does really well. Right? Some tests that look like they're testing something, and then if you look a little bit closer, they don't. Right? So that will really help. Again, some more examples here. Right? Contract and integration gates. We have them already, but make sure that you really think about what you're doing there and how you can verify that. Anything else that I've heard? No, you know all of this stuff. So this was originally devised for a slightly less technical audience. So the thing we talked about, non-determinism, right? So we have more generated tests, we have more flaky tests, we have more noise in the pipeline. When that happens, we all know we stop trusting our test suite. I have consulted with companies where I came in and there was basically a red test dashboard somewhere in a corner of the office. And I said, what you going to do about that? And they're, nothing, it's always like that. So, okay, great, let's delete all your tests. What? No. So, yeah, they're clearly not doing anything for you. If you don't pay attention to what they're doing, then you're probably better off stop wasting time maintaining them. So that usually gets attention, but So, yeah, any of you, flaky test suite that you don't really, I certainly, so I don't have a lot of patience with that, as you probably have gathered from what I just said before. So I'd rather have no test than a flaky test. And if it is not giving me reliable information, what am I even doing with that? Waste of time, waste of resources. Don't do that. Fix it or delete it. AI can help with some of that. So if you have a big flaky test suite, right, you can use AI to analyze some of that. So you can, for example, cluster your failures by signature. Do you have specific areas where those failures are clustered? And then you can have AI kind of auto-quarantine those tests, right? Let it have a run, auto-quarantine all those tests, or maybe just disable them however you manage your test runs, and then run your test suite again until you are to a point where the remaining tests are stable, and then you can go through that and fix stuff. Same on the other end, on the far right, telemetry, right? So AI can be really useful for that, for sifting through log files, for processing some of the findings, for guiding me to where I want to look and where my decision making is needed. I probably don't want it to make decisions, but it is really helpful to kind of condense the information that comes so that I can make better decisions faster. That is a really useful thing. So, so I have talked about that. Sorry for that. So, Monday or maybe tomorrow, right? Pick one of these things that I talked about. Pick one of them and try and see if you can maybe improve things that are being done by using one of your AI tools, whichever this may be. So you probably know which is the one that needs improving the most, right? So I'm not going to tell you, I can't tell you that, of course. But every move you make is one decision, right? So make it once, but you make the decision, make it with judgment, make it with the information you have. Make sure that you make the decision. Don't let a random AI tool make that for you. So, AI didn't break testing. It made bad decisions faster. Our work, though, and probably arguably always has been, is to make good decisions easy. That is what we should be doing. So, we are the people who own what software ships. This ultimately falls back into our responsibility. We probably have thought quite a lot about what good enough means in our running system. So own that, right? If you want to improve how your company does this, don't start with a big AI strategy. Pick one decision, make it in one room. You probably know, again, you know these rooms, right? You probably have an example of that on your calendar already. So you know that, you know your patterns, I don't, but maybe it is a tooling decision that's kind of hanging over your team. Maybe it is a conversation around standards, coding standards, quality standards, whatever it is. I don't know, but you will know, right? Pick that and make sure that you are in there. Because this is the thing, whether we like this AI tooling or not, whether we like this move away from the craftsmanship to the industrialization of the production of code, it is already moving. So if we remove ourselves from the room, the decision will still get made. But we will notice if nobody who actually cares about the craft, who cares about the quality of the craft, was in that room. That will be visible. Right, so AI didn't break testing, made bad decisions faster, so it is our job to be in the rooms where the decisions get made. Thank you.